So in this video, what we're going to try and do is plot functions y equals 4x minus 3 and y equals negative x squared plus 1 over a restricted domain, so between x is negative 3 and x is positive 3. So how we're going to start this off is we're going to try and define a whole range of different x values that we want to plot the function for, and then we're going to calculate the corresponding y values for this first function, and then we should be able to generate a plot of those corresponding x and y values. So let's jump over to MATLAB, and I'm going to do this in a new script. And what we said we wanted first of all was our x values that we're looking at. So there's a couple of different ways that you can do this. One way would be just typing them straight in yourself. So in order to define a vector or a matrix, you need to use the square brackets, and we want to go from negative 3 to positive 3. So you could go through and type them out manually, all right? Although this is a bit of effort, all right? Let me go back. So 1, 2, 3. So we could test that this worked. If we click run, it's going to ask us to save it. So I might just call it practice or something like that. And what we can see that is it's spat out down the bottom here, that vector that I've defined. So this would work. However, you can imagine that if you wanted to have more values between negative 3 and positive 3, it's going to take a lot of effort to keep going back and changing it manually. So a better way to do it would probably be this type of syntax. Right, so what this is saying to MATLAB is start at negative 3, and you're going to go up to a maximum of positive 3, and by default, MATLAB will do this in steps of 1. Right, so it should give us the same kind of thing, except more automatically. So you can see it's going in steps of 1 all the way up from negative 3 to positive 3. Now, if you didn't want to go in steps of 1, which is MATLAB's default, you can change it. All you need to do is pop an extra value in the middle here. So for example, say I wanted to go in steps of 0.5, I'd pop that in the middle between our minimum value and our maximum. And when we run it now, you can see that it is indeed going up in steps of 0.5. It ran out of space just outputting it in the command window, so that's why it's gone on to the next line here. So that's, probably the easiest way to define a vector between two different points. So the next thing that we're going to try and do is define our y value. And I should mention, I've just put this on the end to suppress this x from being spat out the bottom here. So you should see if you run, nothing comes out anymore. Alright, so let's do our y value. And the first function that we wanted to define, if I jump back, was y equals 4x minus 3. And in fact, what I might do is, since we've got two y's we're going to plot, I'll call this one y1, and we'll type in, it needs to be 4 times x, alright, if you put in 4x it's going to cry, I'll show you that, minus 3, so this one's going to be sad, alright, it says unexpected MATLAB expression. That's because you need to tell MATLAB that you want to multiply by x. So if we run now, it's calculated for us the corresponding y value for each of the different x values that we had. Right, and if you ever want to check what your variables are, you can always go up to this workspace area here, and if you double click, it will open up kind of like a spreadsheet of what's inside that variable. So you can see here, right, this is all the x values that we've got defined, and if I click here, it should be the same as what we just spat out. These are all the y values that we have. Right, and they should correspond to each other. So the first y value here corresponds to the first x value that was in the other matrix. Alright, so next up, what we want to try and do is plot them against each other and see what that looks like. So again, I'm going to put this little thing to suppress on the end, and I'm going to come down and tell MATLAB I want to plot. So that's the keyword, and again, it will pop up all the kind of suggestions for how you could write a plot. So most of the time, you're only going to want the first suggestion. So what this is telling you is that you need an x vector, comma, the y vector. If you ever want any more information on this as well, you can come down to the command window and type in help and the name of your function that you want help with, so in this case plot, and it will give you even more details about what is happening. So this one's quite long, but it will describe to you what it's expecting. So plot xy is going to plot a vector y against a vector x, and so on. Alright, so we can do that. So our x vector is called x, the y vector that we want is called y1. So now what should happen is when we run this, it's going to bring up a window which gives us the plot of x versus y. So a few things that you might be interested in doing. One of them is putting a label on the x-axis and a label on the y-axis, and you can even give your graph a title as well. So let's look at the syntax for doing each of those things. So we'll jump back. So if you want to give your x-axis a title, it's the command is x label, and then it's expecting some kind of text in here, or you can give it a variable as well. So let's say we want to give it text. Let's say we want to call it the x-axis or something. So for a text input, we need to give it these little apostrophes to tell it it's text rather than a variable to look up. And again, let's say that I wanted to call it x-axis. So I just type it in and close the bracket. So you can probably guess what the version is for the y-axis. It's going to be y label. And again, we're going to give it some text input, so we need to give it these little apostrophes. And I'll type in here y-axis. The last one I was going to show you was title. So if you want to give your graph a title, the keyword is title. And then you just need to, again, have the little apostrophes, and you can type in whatever you want. So this is the title. So I'm going to click run, and this is what should happen. So now you can see that the x-axis is labeled and the y-axis is labeled with the text that we put in, and we have a title as well, which is the same as what we put in for the title. So the only other thing that we need to kind of do is plot that second function on this same graph. Okay, so if I jump back to the question sheet, so the second function that we want to plot is negative x squared plus 1. So going back to MATLAB then, up here I'm going to define our y2, and we're going to let it equal negative x squared plus 1. Now, what we're going to find is when we run this, it's going to actually throw us an error down the bottom. Alright, you can see here. So it's telling us that we've got an error with using this little power thing in our line. And this is because it's trying to multiply the matrix X by the matrix X using like matrix multiplication. And if you remember back to matrix multiplication, you can only do that with certain matrices with certain sizes. Okay, and in this case, a 1 by 13 matrix multiplied by a 1 by 13 matrix does not work. Okay, so that's why it's complaining at us. So that's not really what we wanted MATLAB to do. What we wanted is for it to take whatever x value that it was looking at and multiply it by itself. So here it would need to be negative 3 times negative 3. So in order to get MATLAB to do that, what we need to do is, one way that we can do it is put a dot in front of our operator, which is the little power symbol here. What that's going to do is tell MATLAB, rather than doing matrix multiplication, it's going to say, okay, whatever is in here, we're going to do like vector multiplication. So it will do the case where it does our individual number, so negative 3, times by itself, negative 3. So if we run it this time, you can see that it didn't throw us an error. And in fact, it will have calculated all the values as we wanted at the corresponding x values. So I'm going to put a little thing on the end here in order to suppress the line now that we know it's working. And now the challenge becomes plotting it. So I'm going to go under here and type in plot. And using the same syntax as before, we want the x values, all right, between negative 3 and positive 3, plotted against the corresponding y values for that second function. Now, what we're going to find is when we run here, we can see that we've only got the one line that's appearing, and really we should have two, okay? Now, the reason that this is happening is because MATLAB by default just overwrites the graph each time you plot something new. So the first line was plotted, but then when you plotted the second one, the first one disappeared and got replaced with this second one. So if you want more than one to be plotted on the same graph, what we need to do is tell MATLAB to hold on, okay? And that means it's going to hold the first graph and the second graph on the same plot. So this is the plot that's come up. Alright, now what you'll see is that there's like different colors to before, and that's because the old runs of this are kind of, I guess, kind of plotted over the top as well now that we've got this hold on actually occurring. So if we were to run this again, what would happen is, again, it would change colors. Alright, that's because we've got like, 3 of this graph on there and 2 of this one. So really what you want to do is shut it, and then you're going to be starting fresh each time you run through the code. Okay, and then it should every time be consistently the same plot that's occurring. Now that can get a bit tedious, especially if you have a whole heap of different plots that are figure windows that are appearing. So there's an automatic function or command that will shut all the windows for you. So it's good practice, I guess, to put that at the top of your code, and that's called close all. So if this figure window is open, what should happen is that when you run the code, it will close it and then reopen a new one each time, alright, as you can see, which makes it a lot easier. A similar command which is quite useful is clear all, which I would definitely recommend. This one, what it does is it clears all your variables each time it runs the code. So anything that happened in a previous run will not infect the next run. So I definitely recommend putting these on the beginning of your codes each time. Alright, so now what we can see is happening though is that we are indeed getting our 2 different plots actually occurring. But what might be nice to have is like a legend that tells us which one is which. So we can do that quite easily. It's just one more line that we need to put on the end, and it's the same kind of format as these other ones. So the command is legend, and again we're going to give it text rather than a variable, so we need to give it these little apostrophes, and then it's just a case of giving it the titles that you want in the legend. So I don't know, let's call ours y1, and then it needs to be separated by a comma, and then whatever the next legend entry, which is y2. So we only have 2 things, but if you are plotting more, you could just keep going with as many entries as you need. So now when we run, what should happen is that a legend ends up popping up on the graph, and you can click and move it as you want. There's also inbuilt functions to tell MATLAB where to put the legend if you're interested in that. And if you want to look at those options, remember we said you could type in help and then the name of the command that you wanted. So in our case, legend. And it would give you some instructions around what to do. So this is the one about changing where it is, location. So the last thing I want to point out for this plotting section is that you can change the colors and the properties of these lines. So I'm pretty bad at remembering what all the different codes are for that. So what I would suggest is each time you want to do it, just type in help plot down the bottom here. And if you scroll up, there's a section where it gives you, here we go, all the different codes for the different formatting types. So there's a whole heap of colors you can pick from, these are like markers that get put on the points that you're plotting, and this is the types of lines that you can have. So let's say that we wanted to make this first line here, let's say we want to make it red, we want to give it circles on the points, and I don't know, let's make it dotted as well. So all we have to do is on the end here we put a comma, and then inside these little apostrophes we give the codes that we want. So it doesn't matter what order, just we can pick. So R for red I'll go with. So we need to pipe in the letter O for circles, and if we want dotted it's going to be this little colon thing. So now if we run, what we should find is that this one here obeys by those formatting requirements that we wanted on it. So you can see it's got circles on each of the points that we're plotting, it's dotted in between, and it's changed it into the color red. So you could of course do that for the second one as well if you were interested in it. So that's pretty much it in terms of this video, and I'll see you in another one.